Okay, hello. I am not here, so I have videotaped the review for you. It will be available on my website also, so make sure if you don't get it all as you go through it in class today that you review it on the website before the test tomorrow. Okay, we're going to start with number 1. We're identifying two chords. So when you look, remember a chord has 2 points on the circle. A chord stops where a secant would continue to go through. So two chords in this circle would be G, H, and I, J. LK is not because it stops on a line, the diameter in the circle. So GH and IJ, C. All right, number 2. A circle is a set of all points in a plane that are equidistant from a given point. Okay, a circle is a set of all points in a plane that are equidistant. Equidistance means the same distance from a given point. Okay, number 3. A line which intersects a circle at exactly one point is called a tangent line. And where that intersects is called the point of tangency, remember, where it intersects. Okay, remember I go very fast, so if you need to sub to pause it or rewind, please do so. Or remember you can watch it at home. Okay, number 4. Identify the diameter for the circle O. So that would be PQ. Remember it have a line above it because it is a line. PQ is your diameter. Okay, number 5. Define a chord. A chord is a segment with endpoints on the circle. A segment with endpoints on the circle. A segment with endpoints on the circle. Define a diameter of a circle. A diameter is a chord that passes through the center. Okay? A chord that passes through the center. Now, a secant of a circle, it says to draw and sketch to illustrate the definition. So, a circle, oh, okay, I'm going to cheat because that looks really bad. So I'm going to pull my little circle right here and draw a circle right here. Now, and I'm going to draw a little line because a secant would just go straight through. Ha! Nice. All right, so your sketch should look something like that. The secant can be anywhere in that circle as long as it goes through it. It has 2 points it touches, but remember it continues. All right, so that's a secant of a circle. Now, define a tangent line. Draw a sketch to illustrate the definition. Okay, so the secant, I didn't actually write the definition. A line that intersects a circle at 2 points. Okay, a line that intersects a circle at 2 points. All right, tangent is a line that intersects at exactly 1 point. Okay, so again, I'm going to copy my circle. All right, so I got another circle. And tangent line would intersect it in exactly 1 point. So I'm just going to make this go like right there. I went too close, but let me move it. Okay, so that would be a tangent line. All right, so definitions, a lot of them on here. So you need to know these. They could be on the test. All right. Number 9, find the measure of ABD. So we're finding the arc. So I want to find ABD. So we're going this way. So all of this. Okay. Now we know this angle is 36. So that means I can find this arc. This is an inscribed angle. Its vertex is on the circle. So you will do 36 times 2 to get this arc, AD. So 36 times 2 gives me 72. Gosh, okay. Okay. 360 minus 72 equals 288. Okay, 360 minus 72 gives you 288 for the arc. So that's your arc, ABD. All right, now angle C would be the exact same thing as B, because remember, they intercept the same arc. So angle C is 36. Okay, so remember, major arc ABD, take that away from 360. To find 288, and then because they intercept the same arc, they are same measure angle. Okay, now let's go to number 10. Okay, in number 10, we have X is 110, WZ is congruent to YZ. So these sides are congruent to each other. Okay? Angle Y is 100. Okay, so angle Z would be opposite this angle. So remember, opposite angles in a quad in a circle. Sorry. Okay. In a circle are supplementary. So 180 minus 110 gives you 70 for Z. Okay. Now, arc WZ is here. Okay, this whole arc, the whole thing, 110 is inscribed angle, so you would double it to get this whole arc. Half of that arc, though, because if you do the whole thing, that means half of this would be the 110 and half of it would be 110. These are equal chords, so these are equal arcs. These are the same. So WZ is going to be 110. Because if you took the whole arc from this angle, doubled it, you would get still half for this part because they're equal. So when you add 110 plus 110, you get 220, but then all I did was take half of it to get 110 again for WZ. Okay, now angle W is across from Y, so that's going to be 80, because 180 minus 100 will leave you with 80. Okay, WX, the arc, WX, okay? Well, you know this is (110) and 110. We knew this part of the arc already. We know that this arc, hold on, the 80 goes with all of this. So if I know 80, double the 80. So is everybody with me? I got a lot of marking. So let me erase all of that and get to where I am with just looking at this one so you can see the true 80, what I'm looking at. Okay, so we know W is 80. So I've got, this is my intercepted arc. So I'm looking at all of this. I know this part from here to here is 110. So 80 times 2 is 160. So this whole thing is 160. Take away the 110, I get what for that part? 6 minus, so I get 50. So now I know this angle was 70. So now I can look at this entire arc right here. Okay. That's 50. I got to find this. We know 70 times 2 is 140. Take away the 50, leaves me with 90. Okay, so this is using your intercepted arcs and all the information you know. So go back through that again. You have to take pieces of it, okay? So we knew that this whole arc over here was 110 and 50 that made the 160. So then we had the 50 here, so we knew this 70 would make this 140. So 140 minus 50 left me with 90. Okay, that one's complicated. I would make sure I review that one several times to make sure I understand all where the parts came from. The easiest part were the angles that are opposite each other because they add up to 180. Okay, number 11. All right, given that DAB and DCB are right angles, so DAB is a right angle, DCB is a right angle, DBC is 42. DBC, so this little angle here is 42. What's the measure of CA, CAB? The actual arc, CAB. Okay. Now we know this angle's 42, so the arc that goes with that would double. You would double 42 and get 84 for this arc. Okay. Okay, so now let me go back through what I just did. Okay. So, angle 42 gave me 84. Now, I have a 180 triangle. I have 42 here, I have 90. So if you do 90 and 42, you get 132 from 180. So that left me with 48 here. So this angle is 48. So now, y'all, if I take and double that to get the arc, 48 times 2 is 96. When you add 96 and 84, you get 180. Okay? So if this side is 180, then I'm left with 180 over here. So now we need CAB. So I know this whole part, I'm going to do that in green, this whole part is 180. So now I add the 84 to it. So 180 plus the 84 would give me my answer, which is 264. So again, you were using the right triangle, and that angle, 90 makes that 180. If I had used my special property, I would know that that is a 180 and then just add the 84. You don't have to prove the 96, because we do know that in a 90 degrees, opposite that's 180. So you don't have to do all that with the 96. You can just say, you know, from the 90 degree that's 180, and 180 plus the 84, use the 42 to get your 84. So I did some extra work there I didn't have to do. All right, so again, looking at 11, you've got angle 42 there. Double it to get 84. You know this 90 makes this 180, and then add the 180 and the 84. So it's a lot easier than I made it out to be to start with. Okay, find the measure of angle 1 down here. Okay, this is my arc that goes with my angle. So half of 140 gives me my angle. So angle 1 would be 70. Half of the arc. Okay, G is 25. H is 20. K is 50. What is GMH? So we're looking at this. Okay, so we're looking at this angle. It does not tell us this is a center. So you can't figure that. So we've just got to look at arcs and measures to get there. Okay? So angle G would give me, if this is 25, then this would be 50. Okay? If this was 20, this is 40. Okay? This is 50, so this is 100. All right, so I found all my arcs from my angles. 25 gave me 50, 20 gave me 40, and 50 gave me 100. Okay, now we have J to L is 90. Okay. Now remember, this angle M is an intersects inside the circle. So you use 1/2 of the arcs added together, the arc sum. So we're going to take 1/2 of 100 plus 90, because I have the intersected arcs, remember, from those angles. And I just did that by adding these together and got 90. So you do 1/2 of 190, and that would give you 95. Be careful, it's not a central angle. You had to use the intersect inside the circle, 1/2 the measure of the arcs. Okay. Number 14. Okay, given RP is 22, RA is 6, PQ is tangent, so this makes this where the radius and the line, it makes it 90 degrees. So you have a right triangle, so 6. So you got 22 as your hypotenuse, so you got 6 squared plus x squared equals 22 squared. Okay, 6 squared plus x squared equals 22 squared. All right, you're going to get the square root of 448 equals 21.2. Okay, so you use Pythagorean theorem. You have 6 squared plus x squared equals 22 squared. All right. 15. Given circle O with radius 5 and OC 3, find the length of AB. Okay, so I've got a radius of 5. This is 3, so I know this is 4 because a 3, 4, 5 triangle. This is a right triangle, so I know that's 4, which would make this 4 because it's going to be split equal there. So that would be AB would be 8 because you could put another triangle, draw that in, they would be congruent triangles. Okay, so all you do is double the 4. All right, number 16. Find the measure of DBC in circle P. All right, it intersects. Oh, wait. Yes, yeah, okay, so it's center. So this is the center. So find the measure of DBC. Oops, I went too far. So we're just finding that arc. Now we know that arc, this is 58. And these are vertical angles. So it'd be 58. And what adds up beside a 58? If you do 180 minus 58, what do you get? 180 minus 58 gives you 122. So 122 would be that angle. So if we're adding up all these arcs, since they're central angles, it'd be 58 plus 122 plus 58. And that should give you 238. 58 plus 58 plus 122. 238. Okay. Now, BCD equals 111. Okay, this is arc. So I got 111 here. DEF, I'm going to put this in a different color, gives me 100. FGH, this next arc, gives me 127. And then HAB, the little one, is 22. Okay, they want us to find FPD, the angle. FPD. Okay, so angle P is outside the circle. So this is one of those where you do half of the difference of the arcs. So you would take half of 100 minus 22. Half of 100 minus 22, so 100 minus 22 is 78, and half of 78 equals 39. So 17 is 39. Now, they gave you all those extra arcs just to make sure you knew which arcs you had to subtract to get the difference there of what you needed. So remember, it's the arcs that are intersected by those lines. So that one and that one. Okay. Number 18. Find the value of x if the measure of angle, the arc, not angle, arc AB is 59. So this is 59, and this one is 47. So these intersect inside the circle, so we're going to do half of the sum of the arcs. Okay, so we get half of 59 plus 47. So 59 plus 47, and half it, divided by 2. 53. Okay, 18. That was 18. 15. Ugh. All right, excuse me. How about 19 now? Write an equation that can be used to find x, then solve the equation for x. Okay. So you've got angle is 65 equals x plus 36 divided by 2. So this is where we multiply by 2 to get rid of this. So 65 times 2. Oh, okay, yeah, find x then. 65 times 2 is 130. So then subtract the 36 and you get 94 for x. Okay. 20, find the measure of angle 1. Okay, it's outside. So you do half of 102 minus 38. And you get 32. Okay, suppose you stand a distance from a circular building. Assume your lines of sight are tangent to the building and make an angle of 22. So you've got a very bad draw of a circle. The angle out here is 22. These are your tangent lines. Okay. What is the measure of the arc of the building that your line of sight intersects? Okay, so this is where you have x so it'll be 360 minus x for this part. So 360 minus x minus x. So you've got 22 equals 1/2, or let's do 360 minus x divided by 2. So this is where you'll multiply by 2 to get rid of this. So you get 44 equals 360 minus 2x. Subtract 360. So you get negative 2x equals negative 316. Divide that by 2. And you get 158. Okay, you're going to divide by negative, so you get a positive 158. Okay, so in this one you had to visualize it like the others. But remember, this was where we had the x and the 360 minus x. Okay. 22. All right, we're finding the lengths of the segments. Okay, so you multiply x times 24 and set it equal to 12 times 8. So 12 times 8, x times, so you're doing that 24x equals 96. 96 divided by 24 is 4. A. Okay, that's number 22. Okay. 23. Now you've got your segment lengths again. This is 15. So you've got 15 squared, if you look at your formula, and you've got x times x plus 40. Because you take the one outside, multiply it to what's added, and this is squared because you just got one side to it. These formulas will be given on your test tomorrow. X squared plus 40x equals 15 squared to 25. Okay. X squared plus 40x minus 225 equals 0. Factor x and x. Factors of 225. Okay. I think my recording got paused. If I already did this, then ignore. I'm redoing. When I factored this, I don't know that you saw me do the factors because I paused it and came back. So 45 and 5 are my factors. X equals negative 45 won't work. 5 works. So that's your answer. Use your answers here to help you get your factors. If I've already done 24, then just ignore me doing this again. So 9 times 9 plus 15 equals 8 times x. You're doing your lengths of your segments. Remember, I will give you these formulas on the test. So 9 plus 15 gives me 24, and 24 times 9 gives me 216. When you divide by 8, you get 27. So 27 for number 24. Sorry if my recording did not get paused there. I hope I got it picked back up where it's supposed to be. All right, number 25. For a circle with a radius of 5 feet, find the length of an arc. Okay, so this is the measure the arc divided by 360 times 2 pi r, your circumference. Okay, so they give us the measure of the arc is 28. So we've got 28 divided by 360, and the radius is 5. So we're just plugging it in, and we're keeping it in terms of pi. So this is going to be 10 pi, 28, so you got over 360. So 280 pi over 360. So when I simplify that fraction, 280 divided by 360, math fraction on my calculator, I get 7 over 9 pi. So it is A. Okay. Now, number 26. Find the length of a 40-degree arc in a circle with a radius of 4. Okay, so arc length again, 360 times 2 pi r. Oops. Okay, find the length of it. You've got a 40-degree arc with a radius 4. So we've got 4 times 8 times 40. So 40 times 8, or 320 over 360. So simplify your fraction, math fraction, and it gives you 8 over 9 pi. Okay, an automobile has a 20-inch diameter wheel. If the wheels revolve 3 times after the brakes were applied, the stopping distance was approximately how many feet? Okay, now realize this is inches. So you're going to have to make this feet in order for this to work. You've got different units. An automobile has 20-inch diameter wheels. So if the wheels revolve 3 times, so we're going around 3 times. This is the measured distance would be circumference. So we got 2 pi r, and we're going to do that 3 times, right? Okay, our diameter is going to be 20 inches. So radius is 10 inches. How many feet is 10 inches? So you have 12 inches in a foot, so it's less than a foot. So how much So, okay, so when you take 10 inches to make it feet, you get 10 divided by, sorry, let me try that again. 10 divided by 12 equals 0.833. So you're going to plug that in for your radius. And when you multiply 3 times 2 times pi times radius, because you are going to use pi this time, you get 15.7 feet. Okay, 15.7. All right. 28. A park has a circular swimming pool. The diameter of the pool is 19. What is the distance traveled if you swim around the edge of the pool once? Okay, so diameter is 19. You're going to go around the pool once. So 2 pi r is your distance around the pool. So you would have radius half of 19. So 9.5. Well, you got the diameter, so you can just use it because I'm just multiplying by 2 again. Okay, times 3.14. So you get 59.66. Okay? All right. Now the area of the sector. Okay, so now we're going to do area of a sector, which means we have to take the arc divided by 360 times the area, pi r squared. Okay, so you have the piece of the pie, so it's going to be 64 over 360 times pi 5 squared. And we're leaving this in terms of pi, so you're just going to multiply 25 times 64. You get 1600 over 360 pi. So 1600 divided by 360 and simplify. 40 over 9 pi. Okay. Okay, find the area of the shaded sector to the nearest whole number. So we got 60 over 360 times pi 12 squared. Okay, so multiply and divide by 360. You get 24 times pi and you get 75 because it wants the whole number. Okay, now this is 11, so you've got 180 divided by 360 times pi times 5.5 squared, and that's going to be half of that because 180 over 360 is 1/2. So then multiply by pi and you get 48. Okay, that's your area of your sectors. Okay. That's 30 and 31. Okay, 32. In circle O, the measure of AB is 120, and the area of the sector with the central angle AOB is 48 pi inches squared. Find the radius of the circle O and the length of AB. Okay, so we've got an arc of 120. Okay, with a central angle of 48. The area of the sector is 48 pi. Okay, pi r squared. So I'm setting up my equation. So this was my arc over the 360 pi r squared. They gave me the area of the sector. This is my formula for an area of a sector. They want me to find r. So I'm going to have to multiply by 360 on both sides. Okay. Now go ahead, you can mark out your pi's because they would cancel out. So 48 times 360 is 17,280 equals 120r squared. So now divide by 120 on both sides. And you get a lovely 144. So R would be 12. Okay, so that's your radius, but they want the length of AB also. So the arc length would be 120 over 360 times 2 pi r. And now we know the r is 12. So do your multiplication. 120 times 2 times 12 times pi divided by 360. I'm just doing all my math together. So that would give me 25.1 inches. And this was 12 inches. Okay, so this is the arc length. So I wanted you to find the radius and then use that to find your arc length. Okay, write the standard equation of a circle with its center at the origin and radius 3. Okay, if your center is at the origin, that means you really got x minus 0 squared plus y minus 0 squared, and it's r squared, so 3 squared, so it's going to be 9. So that would be C. Okay? They gave you all the information, you just have to plug it into your equation, which is x minus h squared plus y minus k squared equals r squared. So don't forget that. Okay, 34. You have a circle represented here. Write an equation for the boundary where the company delivers and find its radius. Each unit represents one block. So here would be our center. And it goes 1, 2, 3, 4, 5. So my radius is 5. My center is at 1, 2, 3, 4, 5, 1, 2. So 5, 2. So my equation should be x minus 5 squared plus y minus 2 squared equals 5 squared. Okay? X minus 5 plus y minus 2 equals 5 squared, 25. X minus 5 squared. Okay. Now, how many blocks is R? What is my radius? My radius is 5. Okay, so this is the correct answer. Does everybody see that? X minus 5, y minus 2, 5 squared is 25, but my radius was the 5 because this is R squared. So 5 is your R. Okay. 35. Write the standard equation of a circle with center negative 3, 5 and radius 5 halves. Okay. So it would be x plus 3 squared plus y minus 5 squared equals 25 over 4. Because when you square 5, you get 25. When you square 2, you get 4. All right, 36. Sketch the graph of x minus 4 squared plus y plus 3 squared equals 25. Label your coordinates in the center. My center is going to be 4, 1, 2, 3, 4, and then negative 3. 1, 2, 3. Okay, is that right? 1, 2, 3, 4, and negative 3. Yes, 1, 2, 3. All right, so then my circle, I got to go 5 over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Up, over to the left. 1, 2, 3, 4, 5. And 1, 2, 3, 4. Move. 1, 2, 3, 4. Oh gosh, try that again. 1, 2, 3, 4, 5. Okay, now you're going to make this lovely circle. And mine is going to look like something else, an alien circle. So, okay. Maybe if I tried my real circle thing over here and started here and went out. I could do better. All right, that looks a little better. Okay. Okay. All you do is find your center and then go 5 over and 5 up and 5. I didn't go all the way 5 there and 5 down. Okay. And remember your center's opposite, 4 and -3. Okay, that's 36. Okay, 37. No, 36. I did 36. Okay, 37, sorry. X plus 2 squared plus y plus 1 squared equals 9. So you are looking for the graph who has a -2, -1 center with a radius of 3. Okay. So a -2, -1 center with a radius 3. So that's going to be, hold on. All right, this one, we know it's not this one or this one, okay? So check it from there. Okay, so when you're looking at these, remember the center, -2, -1, and this is by 2s, 2, 4, 6, 8. So to get 3 over, you would be just a little past that one and that one. So this is your correct, oops, as my board moves, this is your correct answer. Okay, -2, -1, radius 3. So C would be your correct answer. All right, looking at 38, the graph shows the outline of a sunken garden. What equation describes the circle? Okay, so you're at 40, 60, so you can mark out those two. So you're at -40, -60, so you're still looking at both these. Now, how far is, what is my radius here? So to here, from here to here, so I go 20, 40, 60, because I'm going all the way to 100. So it'd be 20, 40, 60, so it's C, 60 squared. Okay, next. Oh. Okay, 20, 39. Which point is the center of the circle represented by the following equation? Okay, this is where you're going to have to group and complete the square here. Okay, so you half it, square it, subtract it. Half it, square it's going to be, half of it's 3, 9. So subtract 9. Half of 4 is 2, 2 squared is 4, subtract 4. So -16, so you're going to have x plus 3 squared plus y plus 2 squared equals 16. So it wants to know which point is the center of the circle. So it would be -3, -2. Because remember, it's opposite. Okay. What is the radius of the circle described by the equation? All right, again, we're going to complete the square. X squared plus 2y, not 2y. How about -8x? Let's group our x's. Okay, plus blank plus y squared plus 2y plus blank, and you got plus 8 equals 0. Okay, so half of 8 is 4, 4 squared 16, subtract 16. Half of 2 is 1, 1 squared is 1, subtract 1. So you've got +8 and -17. So -17 and +8 gives you a -9. So you would have x squared minus 4 squared plus y plus 1 squared equals 9. So your radius would be 3. Okay. That wraps up this review. It is a long video. As you go through it with the sub, I hope you can pause and keep going back if you need to. That wraps up all of circles. Good luck on the test tomorrow, and I'll see you after Christmas. Have a Merry Christmas. Thanks. Bye.